Damn, dude. Oh, yeah, that's right. Oops. Oops. Alright, let me bring up my notes. What the hell is this? Oh, right. Can I delete this? Yeah, why not, right? Oh my god, why is there so much? I'll keep. I'll keep one. Yes. Okay. So, for energy, I think one of the simplest things to know is I forgot the notation. It's gonna be Ugo plus Uso plus Kyo. Oh no, I'm so good. Let me change colors here. Equals Ugif, Usif, and Kef. Right? So, that's pretty much all you need for like a quiz kind of thing. So, a quiz could be like, I have one really like, not super difficult one, but it's would trip people up. So you could have something like, um, these are okay. Whatever. I'll just use this one. If you have like a ball, right, and it's dropping, and you're saying find the velocity just before it hits the ground, then you would look at these values, right? And so you go, okay, so let's say it's initially stationary, right? So someone's holding it and then they drop it, and so it starts to fall. So that means there's no spring involved. It's initially not moving. Um, it hits the floor, so there's no gravitational energy anymore. There's no spring involved. So you got Ugo equals Kef, right? Ugo is mgh, and Kef is 1/2 mv squared. If you have the masses cancel out, so it doesn't really matter. And so if you have the gravity, which you do, if you have the height, and then, I mean, that's pretty much it. You just do V equals 2gh, and that's how you find the velocity just before it hits the ground. You could do something simple like that. You could make it a little more complicated. Like maybe this ball was initially you could say this ball was initially thrown down at some speed and it's at a height, right? And then you could put like a spring here and say a really long spring, right? And then you could say how far does the spring compress, right? So you go back here, you go, there is an initial height, there's no initial spring, and there's initial velocity. And then all we want is how far the spring compresses, so we want this one. So this ignore and this ignore, because assuming the ball stops when it fully compresses. So then you go mgh plus 1/2 mv squared equals 1/2 kx squared. And then assuming you know k m g h v or v initial, then you could find for the compression of the spring right here. So these are your quizzes, so you could kind of decide how difficult you might want to make it. Like my friend, he made his quizzes like super simple, right? His were something like the first one where like you got a ball dropping. He has like a part A and he had a part B. Like find this speed of the ball right before they hit the ground, and they were super simple. The quizzes I did were super complicated because I was peacocking a bit. But this is another example of a quiz you could do, and you can make up the values for K, H, V initial, all that. But if you want like a complicated one that I probably would have done if, which I still have the other two, but they're complicated, so I don't. Besides, you want to do energy. I didn't do energy. So let's say you have this bank curve. Actually, hold on. Let me do this. Circle. And then yeah. Right there. That's about it. So, fuck. Which I think this is an old problem I did a long time ago. So they might, I don't know, they might find it, but I doubt they will. So let's say you have this curve right here, and there's a block right here, right, of mass M, and it goes down, and it slides, and it goes that way, right? Let's say this bank curve right here, there's no friction. And then past the curvature, so right here, there is friction. So friction, yes. And so, you know, my ass would probably just be like, I'm just reading off what I have here. Where's the circle one? No. How do I do this? What? 90. There we go. No, whatever. It's fine. I'll live. So, is that on it? Yeah, it is. Okay, we do this. Right now, I'm doing too much. I should just do a real quick one, but whatever. So let's say we know. Let's say we know the mass. We know. Damn. Okay. Where is my colors? What? Why is it? Okay. Let's say we know M. We know the friction of the surface. K. We know the radius of this curvature. And is that what we need? Yeah. Look at that. So we know these three. That means we could just be like, part A, find the velocity at the end of the curve. Find V at curve end, let's say that. And then B, you could be like, find how far the block goes before it stops, right? Because there's friction here, there's no friction here. So the block is going to move a certain distance and come to a stop. So we could find that distance. So find how far block go. And so there's probably one I'd do. This is it's kind of overly complicated for like a little quiz. Oh, is it? I don't know. Either way. So like part A, you would go into the energy, right? So it starts off at an initial height, right? And then it goes into all energy. I mean, that's simple as that. There might be some speedage due to the curve, but I think you could just ignore that, to be honest with you. So you could do you could do mgh equals 1/2 mv squared for part A, solve for V, and you get 2GH, or in this case, I guess it'd be R, right? Yeah, because this is because this is R, so this is the height of the circle. It would be 2GR, square root 2GR. And that would be your V. And then for part B, you could just kind of do some of the forces in the X direction. There's going to be a friction force, and then the inertia of the block. Friction is equal to the coefficient of friction times the normal force, which is just going to be the weight equals ma. And then you could solve for A, which is going to be mu k times g, which you would know g. And then, negative. There you go. And then you could plug into some equation like change in V's, I think squared, right? V0 squared plus 2a change in x. The final velocity is going to be 0. The initial velocity is what you got for part A. So it's, not you. 0 square root 2gr squared plus 2, and then A is going to be negative mu kg, so it's going to be negative mu kg, change in x, and then you solve for x, and that tells you how far the block goes along this x direction. Overly complicated for this one, but I mean, pick your poison. If I were to pick one, I mean, the second one is pretty good practice. If you need a refresher, for that one I just did like... Let's say a marble drops. So this is M. A marble drops from a height of... We could say... I can't want to use a different color. Whatever, it doesn't matter. Yeah, right? Okay. I'll use red. This is a spring. And it has initial velocity and it drops from height h. Right? So you could do like a marble drops from an initial height and initial speed of whatever this is. And this marble comes to a stop and lands on a spring. So lands on this spring. And then you could say find the max compression of the spring, right? So again, it'd be, just to write it quick, Ugo, Uso, Kio, equals Ugif, Usif, plus Kef, right? And conservation, let's do this. Well, this is just a conservation of energy, right? Energy isn't created, it isn't destroyed in this perfect world. So, and then you start off with an initial height and an initial velocity, but there is no initial spring here, so cancel that out. And then it lands on this thing, comes to a stop, so there's no height and there's no velocity. So you could do Ugo plus Kio equals Usef, which is mgh, which you know, 1/2 mv squared, which you would know, and then 1/2 kx squared, which assuming you would also know k because you're making up the quiz. This is your quiz. And then you solve for x and that's how far the spring compresses. That's a thumbs up.